I'm Tommy Young, and I'm so glad that you're here. Dr. Porter, thank you for being paired with me. I feel it like an honor to be paired with you. I'll show you all my obituary. Right here, the main thing I wanted you to concern and let you know is that I've been dealing with irrigation practically since the 1980s. My father had a heart attack in 1980, and that's a monumental time for us. He survived it, but we decided that instead of having 300 acres of irrigated that land from then on, we were going to try to irrigate it all. And so I wanted you to also know that I have been a center pivot irrigation dealer for T&L irrigation systems since 1988. And so every year we try to improve what we've done with irrigation on our farm. The first thing I want to point out to you all is that no technology at all is worth a hill of beans unless your systems or your polypipe or whatever you're doing, your well and all of that is not efficient. And so what you need to do before you do and try to implement any kind of plan on your farm is to be efficient. The first thing I would suggest is how many of you check your RPMs on your units, and just to make certain that what you're doing is correct. Everyone goes out in the spring and they fire up their wells and they assume that everything there is correct. So I would highly recommend that you check your RPMs and make certain that you're turning 1760 on your wellhead, because predominantly that's all what wellheads are supposed to do. They turn at 1760. You might have a different ratio gear head, but nonetheless, the well, that's its operating efficiency at that RPM. The way you can know this is to go with a flow meter. And you say, well, I don't want to spend that much money on every well to put flow meters. Well, I would say that in reality it's probably worth it in the long run, but you can take flow meters and go from well to well. So you need to make certain that whatever type system you're doing, whether it be center pivots, whether it be polypipe or flood, that you're doing it efficiently and that your equipment is correct. I'm going to probably aim a lot of this towards center pivots, but you can take it or leave it ever how you want to. But nonetheless, the same exact criteria, when we get to the end of this presentation, you'll understand. This is going hand in hand with the spring. Getting your system underway, things that you need to be doing now. How many of you go out and actually check every nozzle and make certain that it's turning properly, or do you just assume that over years and years of time that it's doing what it's supposed to be doing from a windshield of a pickup truck? I would highly recommend that you check your nozzles. One nozzle, time you make that entire circle, you've lost a lot of acres there if it's not putting out any water. And I had a man tell me at lunch, and I agree with him wholeheartedly, if you're getting into drones, it's a good way to check your nozzles. And I said, well, my nephew, he's flying up and down our pivots and looking at our nozzles now. He said, have you ever thought about that guy that's walking down through there and he gets to one and there's no nozzle? He said, we've tied a nozzle to it and flew it to him before to save him having to walk back. So make a long story short, there's all different kinds of ways. Dr. Chris Henry is with us in the room today, and I want to have to commend him. He's done a lot of work on my farm, and I've embraced it. And this is some of the work that he's done with his staff, is to determine uniformity on a center pivot. And he came out there, and we waited till the corn got too tall because it kept raining and raining. But nonetheless, he set up these stations here and ran the pivot across it. And this is in more detail. It's almost finite with the way he placed these out across the pivot, let the pivot come across. Notice the gap to determine the uniformity of it. And you'll see the collection cup there that was used to determine how much that particular nozzle is putting out. Guys, what we want here is we want an efficient pivot that's putting out the same all the way down through it. And that's basically what we have with this particular nozzling package. You can't very well go about the first here, because that's the first span. You're always going to have a little discrepancy in the first span. But notice the rest of the pivot here, how uniform we are. I'm not trying to push nozzles here, but I will say that the R3000s by Nelson are very good, very efficient. and they do a really good job of being uniform, and we've started going with those exclusively on our farm and in our sales. But if you'll notice here that we was trying to put out an inch, and that's what we've done here. I'm very happy with the uniformity of it. And so all this is being said to you to think that, well, we're not even to the point of thinking about how to use technology to determine when to irrigate. We're just trying to get our systems up to par. If you were flood irrigating, for example, which many of you probably do, you may think that your well is doing good when you go out there and you just see it putting out water out the end pipe. But guess what? If it's been there 25 years, it's probably worn out. You probably need to check those things. You might be burning a whole lot more fuel, energy, or natural gas, whatever your source may be, and you could be more efficient. You might spend $7,000 replacing your pump, but make that back in a year or two because of the inefficiency of the previous pump that was in there originally. Notice what I have here, the evolution of introducing technology. And what we're talking about here is way back then when I was a young whippersnapper and we didn't irrigate at all, and we was able to go to the lake just about all through June, July, and August. We didn't have anything to do. Then we had to start irrigating. Well, this is the way we checked for soil moisture at that time. And basically what we did was just simply go out there and, well, it's dry, we need to irrigate. And so with that said, that's the process that we used, and we were laughing at my joke here, but really that's about how it was done. You waited, and by the time it was this point, it's too late, guys. We're already past the point of no return. So guess what? My caveman here, and I want you to notice him. He's an employee of mine. He would kill me if he knew I was calling him a caveman, but nonetheless, he looks like one. But we used a new tool there called a shovel. Instead of using our foot, well, what we did is we take a shovel and we would simply dig into the soil and see if we've got moisture. Well, that worked for a while, and then guess what? We've got new tools. And Chris Henry introduced this to me. And this tool here is a core, and it works really well. And it beats that shovel all to heck. And I kid you not, you can take it out and you can see the actual depths of your soil. Now the main purpose of this is that what you want to do is you do not want to let your subsoil moisture and your topsoil moisture ever separate. I was taught this years and years ago when we first got into the center pivot business. If you let your subsoil moisture get away, guys, especially with the center pivot, you'll never catch up. And so what you've got to do is keep those together. So that is a very good tool in determining that. And so, as you see, my wife, she was with me this summer, and she said, well, hey, let me see if I can do that. And that point there is anyone can do that. Not that I'm saying that she's a blind, but nonetheless, she can manage the tool. But what we're looking at here today, and what the point of this whole thing that I'm trying to get across to you is that technology is on the horizon in the grand scheme of things. What we first started learning was, and research was done, that it was important to know what the crop needed. Everyone just assumed, well, if I go out and put out 1/4 of an inch on that corn every 10 days, man, it'll make a bumper crop. That's not true. We need 0.35 inches per day, and that's proven. And on cotton, we need 0.23. So guess what? I'm not going to go into a center pivot speech because that's the last time I spoke at this conference. That's what I talked about, was how to make a center pivot efficient. But I guess what I'm telling you is those crops need a lot of water, and they need it at the correct time. So what we're saying here is that, guess what, 0.35 inches per day, what's that work out to? Over 2 inches per week on corn. So theoretically, if your pivot's capable of making a circle putting out 1 inch in 3 days, if it's not, you need to increase your gallons per minute. But if it's capable, guess what? You're going to probably be running 2 times a week. I used to tell the old story. I used to like to go to the lake. And so I'd like to turn it on after church on Sunday night when I'd get home from the lake. And then on Friday at noon when I'd try to get away to go to the lake. So that's why you need a center pivot that will put out that amount of water to be able to do that job. Well, if you don't have that, and using this term, pissing in the wind, excuse my language, ma'am, you're wasting your time, because what you're doing, your subsoil moisture is going to evade your topsoil moisture, and you're not being able to put out enough. So you need capacity there in order to do the job. So this is some of that technology that we're learning. We can see here specifically that during the period from about 2 weeks prior to silking, we're talking about corn here, 2 weeks prior to silking until 2 to 3 weeks after silking, the water use on days with the temperatures in the upper 90s can be 0.3 inches. This 4 to 5 week period is the most critical time to make sure irrigation is applied as needed to satisfy the water needs. So guess what? If you've done a great job watering prior, and you would have missed this critical period, all that you've done before, you just would have not even had it going. So we need to be on time with our watering. And so we need to be more pinpointed with our watering. Here, this kind of is a good point here, I think. When your fertilizer uptake, it's tasseling to soft dough. You have 20 to 60% yield reduction during this period of time. So if you miss the watering, if you're critical time there, you miss it, then you're going to lose a considerable amount of yield at that time. So what are we saying here? We're saying timing is everything when it comes to watering. So in that evolution of getting more critical, timely water to the field, we start doing more things. So here we're looking at rain gauges. Well, I had an old gentleman, sold him a center pivot years ago. It had no rain gauge, so anyway, it rained about 1/4 of an inch. He had his pivot going. He said, well, should I turn it off? And I said, why? And he said, well, it rained. And I said, well, it didn't rain enough. So what we need to do here is all these different fields on my farm, we have a rain gauge at every point. Some fields, we have a rain gauge at both sides of the field. So it's very critical that you take a rain gauge and put up where you know what you got. And then after you do that, then you can go on to these type methods here, which is what we have evolved into using and have been using for quite some time. It's been the most effective tool we've had up until this point, and that's the irrigation scheduler. If any of you can balance a checkbook, this is kind of the way this works. What you do is when you're fully saturated, your bank account is full. When it starts to erode away, or the moisture starts going from the soil, this scheduler here, using a computerized system, knows what the uptake of that corn is, and it starts taking it away. So as it takes it away, guess what? It triggers a point here to where you need to recharge. And so that gives you that point there that you can utilize that schedule. So what we're doing is using the schedule to determine when we make our circles, or when we flood irrigate, when we turn our poly pipe on, that sort of thing. But guess what, guys? This doesn't do a whole lot to talk about this cloudiness that we've had. It doesn't talk about, well, the sun is covered, things of that nature. It doesn't determine actual soil moisture. It just predicts it based upon units of measure using the computer system. So guess what we've done here now? And this is a modern version, but Chris, I think, took my old one away from me because it wasn't any good. But they started coming out with what they referred to as a moisture probe. Well, what I don't like about this is simply the fact that you have to put that in irrigation water on the field that you're using. You have to calibrate it, and guess what? You can stick it in the ground, and it's got a little meter here that lets you determine whether or not you need to start irrigating. If you'll notice here, see the green? So this gives you a little bit of an educated technological advantage to knowing what actual soil moisture is. You're not taking your foot and just guessing. So we've came a long way from that, I guess you'd say, the kicking of the dirt to the shovel to this device here. But nonetheless, you have to use it. If you got 30-something center pivots, it's kind of hard to know how to manage all this. You're working, by the time you've got around with this, you're already behind. So nonetheless, with this said, this is just another evolution in the stages of getting to the technological advantage that I feel like we have today. Here's where I feel like we're at today. We're using sensors that have been placed into the field, and they're placed in there at the time the corn emerged. When the corn has emerged, then what we've done is we're mimicking the root zone that that probe is put into, the sensor is put into. You don't want to wait and put this in after the corn's 4 feet tall. I'm using Chris as another example there. I wanted to do this in soybeans after I got finished with the corn, move them away. And he said, well, you won't be any use to you because the soybean plant's already too large. It's done. You can't re-mimic what the root zone was in the soybeans. So nonetheless, the main thing we're trying to determine here is when to refill, when to trigger that irrigation and be more efficient in doing it. This is a conservation conference. That's what we're trying to do, is conserve. Guys, I don't know how y'all feel about it, but my margin right now is about there. It's negative margin. I mean, I need to save everywhere I can possibly save, and irrigation is a good place to do that, but you don't want to do it in such a way that you're going to kill yourself in yield. So what we've got to do is figure out a way to save. What we're going to have to determine here is the time to irrigate and not lose yield. And that's what this is all about. These are sensors. I'm not promoting one sensor over the other. There's volumetric sensors. There's all kinds of sensors. But what you need to do is determine the soil that you're using and that you have, and use the sensor that's appropriate and one that you feel comfortable in doing. Personally, the ones that Chris has been helping me put on my farm, I feel comfortable in it because the majority of my soil is sandy. I will have to have one asterisk beside what you're doing with the sensors. Is realistically what happens is that when you're using a sensor, it's supposed to measure the amount of water or moisture that's in the soil at the appropriate depths. Well, I am not convinced that we can just take any soil type and determine that that is appropriate for everybody. I think there's different soils and different types and different ways that we can use our graphs that we're going to see here momentarily. But nonetheless, we can work on that and get that fine-tuned to your own farm. Key things that you need to know about sensors. The probe should be installed in the majority soil type of the field determined by maps. Or you know your soil, you know your fields. You need to determine where you're going to put that sensor. The probe should be installed once the crop is emerged between two healthy plants with a good stand. Poor installation can result in bad data. And the probe must be fully installed, flush with the ground on I can't even say that word. Stall probes. Soil type variability. Notice here what we have. If you were going to install a probe on this, say to encompass one probe to sensor to encompass all of this, in my opinion, what I would do is I would pick probably the red or the yellow, and that way you would have the most. When that sensor sits where you were, the majority of the rest of the farm that you're looking at there would be the same. Probe must be fully and properly installed. These are just different aspects of how to properly install one. In other words, put one in, if it's not properly installed, it's not doing any good either. And guess what? This is peanuts. You'll be able to see that all year long. Cornfields are a little different. You need to find out where you put them, and you need to make certain you can remember where you put them. Is that right, Chris? Bad data is bad installation. Notice my caveman. Look where he's at now. He's a happy camper. because now he's using his phone, and believe you me, he's on his phone a lot. You know, I mean, this is just like secondhand to him, so he is tickled to death. But in all seriousness, what I have on my phone right now is my entire farm. We have went with, at the beginning, and I'll have to get on to a side note here just a second, that we had 4 half-mile long center pivots among 30-something quarter-milers. Well, this fella that does all my center pivot checking, he wear out a pickup truck every year checking those things. And the way we do it is he gets up every morning, that's his sole purpose in life, is to get up and circle them up. Well, he may go out to a half-miler there and it be shut down. He looks at everything, checks everything, starts it back up. There's nothing to say that the moment he gets out of sight, shuts down again. So he checks it again, and he calls it a flyby in the evening, shuts down, he starts it up again. Nothing to say that it's not going to shut down again. So guess what? He's lost 12 hours plus another 12 hours, and by that time he better be walking the thing out. But nonetheless, 24 hours on a half-mile long pivot over time means a lot. Guess what we're doing here? We're losing our subsoil, topsoil, because we can't keep them together. So what I've done is every center pivot I own has an AgSense monitor on it. Not pushing AgSense. Use whatever means of device you want to, but I like AgSense. And I can know, I get a text message if that pivot shuts down, get a text message when it started. And I know precisely, if I am in California and my guys are back home supposed to be watching things, and I get a text message and that thing doesn't restart in about an hour, I'm making a phone call. So what it's done for me is ensured me of those half-mile long pivots, and all my pivots now, they're running. They need to be running. And so what this is showing you here, these are the sensors that I've got in the field. And we're going to incorporate more of them because I really like them now. Assessing the data. Now I'm going to have to read this. WagNet has a simple, easy to understand user interface that makes it possible to monitor and control all your AgSense devices from virtually anywhere in the world. And so what you're seeing here is, and I had to say this AgSense farm, it could be whatever. But see, this is showing that the pivot is running. It's showing the different sensor locations, and I'm able to click on them here and monitor them with my device. You think, well, you don't have to be an Einstein, guys, to understand this. It's that simple. What we're trying to do here is simply save. I keep referring to Chris, and I apologize for that, and I apologize to him, but when we first started talking about this, it was so hard for me to get away from the irrigation scheduler because that pivot needed to be running. You needed to keep a goldfish living in that corn. And so what I have found, though, that the sensors are doing for me is being able to get me further out. So if I start up my pivot there, and I am running it, and I'm saturated, and guess what? If the sensor doesn't say I need to start it 3 days later, I don't start it. Well, say I get to push that on out. Well, if I push that on out, then guess what happens is there's a 70% chance of rain. And guess what? I get it. So I have saved that amount of time in my irrigation, and over time, over the year, over all the systems, if you've done that, you've saved a lot of fuel, a lot of energy, and a lot of wear and tear. The sensors are usually placed at different root zones, and the root zones here need to be determined, and this lets you determine exactly where the moisture is throughout the year. I want you all to know that I'm not a professor. I'm just giving you an overview of how I'm viewing it from a farmer's standpoint. But we have to determine the stress line. That's the trigger line. That's the one right now that I feel like we're still making finite based on soil type. But with that said, notice here, we've got a sensor at 6 inches, 18 inches, 12 inches, and 30 inches. And these are recharge points. None of my lines ever got below what I refer to as a stress line. But what we want to try to do is keep a straight line there on a certain root zone that you feel like comfortable with. Obviously your 6-inch one is going to fluctuate, but your other ones are going to try to remain pretty much constant throughout the growing season. And what that means is you've kept your subsoil and your topsoil together. In summary, service and maintain your systems, no matter what you're using. Whether it be just a well and you're pumping water out, know what it's pumping. I've always used this little phrase. You can be disking with a 40-20 and a 15-foot disc going through the field, or you can be disking with the largest four-wheel drive tractor there is and a 45-foot disc. Maybe using more fuel, but which one does the work? Which one gets you done? So make certain your system is efficient. I'll properly check and calibrate the applications. Schedule your irrigation timely with some type of system. We're way beyond kicking it with our feet, guys. Way beyond that now. There's so many systems out there, so many things that you can be using for free. Irrigation scheduler, the Delta Plastics program that they have for hole punch. Guys, when that first came out, everyone was so skeptical, and faucet program was so difficult. But guys, it's there now for you to use. There's not a field, I don't care if it's a 15-acre field or a 400-acre field, that I wouldn't use that on. And my guys like it too, because that saves a whole lot of sticking holes, plugging up, and making mistakes. And don't be afraid of technology. That's what I'm trying to be here today. And I told Dr. Porter that I was going to try to encourage you as a meager farmer to embrace technology, because I believe it's going to pay. I believe it's worthwhile. And the benefits far outweigh the cost. Hope you all have a great year. And do you have any questions for me? Well, thank you very much. Don't none of you leave until you